8.3 Rotational Dynamics. The learning objective is to define and use moment of inertia of rigid body, different shapes of rigid body, sphere, cylinder, ring, disc, and rod. So I is equals to summation of mr squared. B, state and use torque. Torque is equals to I alpha. I is the moment of inertia and alpha is the angular acceleration. So what is moment of inertia? Moment of inertia, the capital letter I, is representing the property of an object to resist changes in its rotational state of motion. This body is already moving in rotational motion and it has the inertia to keep moving to resist any changes. Moment of inertia depends on the mass and the distribution of mass with respect to the axis of rotation. When mass is close to axis of rotation, which means that the r is small, when the r is small, I will become small. So small I indicates that the resistance is small, therefore it is easy to start rotating. Okay, for the next diagram, when the mass farther from the axis, okay, so the r is greater. When the r is greater, the moment of inertia is greater. And this shows that the resistance is very, very high, so it is harder to start rotating. Okay, so you have to remember I is the resistance of an object to resist changes in its rotational motion. Okay, dia akan cuba untuk terus bergerak dalam rotational motion. So bila I dia tinggi, bermaksud resistance dia tinggi, susah untuk rotate. Bila I dia rendah, resistance dia rendah, jadi senang untuk rotate. The formula for moment inertia of a particle. So the keyword here is particle. The formula is I equals to mr squared. Okay, so let's say this is the mass of the particle from the axis of rotation. Okay, so this particle is moving in rotation. So to calculate the inertia, the resistance to resist any changes is equals to mr squared. Moment inertia is a scalar quantity and the unit is kg from mass and meter from r. So kg m squared. Okay, next, the moment inertia of particles, system or rigid body is the sum of the moments inertia of each individual particle of the body. So this is the rigid body. On this rigid body, there are several individual particles on the body. So M1, first particle, M2, another particle, M3 is another particle, and more. And then the moment inertia of the whole system is the summation of the inertia for the individual particle. Okay, so that's why you can see summation over here. Okay, next, different shapes of rigid body will have different formula on how to calculate the moment of inertia. For example, for the thin cylinder, hoop or ring, I is equals to mr squared. So this is the mass of the rigid body and r is the radius of the ring. And then we have thin rod. Thin rod is 1 over 12 ml squared. So L is the length of the rod. Next, solid cylinder or disc. For this one, the formula is 1 over 2 mr squared. For solid sphere, 2 over 5 mr squared. For hollow sphere, kosong di dalam, 2 over 3 mr squared. So all the formula for the moment of inertia for different types of shapes, you can refer to the list of formula. Okay, when you do your assignment, make sure that you refer to the question what type of shape of rigid body, then you choose the formula from the list of formula. Okay, it's either solid sphere, ring, solid cylinder, or disc, or rod. Okay, so some of the concept for rotational dynamics that you need to understand is that moment of inertia is the resistance to change in its angular motion. Moment inertia of particle, this is formula I equals to mr squared. The unit is kg m squared. Moment of inertia depends on its shape. Okay, so different shape has different formula and the mass and also the axis of rotation, because the axis of rotation will determine the value of r. Okay, so here we're going to look at another formula for torque. Okay, last time we have used F dot D, where F is the force and D is the moment arm. The angle between them is 90 degrees. Another formula for torque for a rigid body already moving with a certain angular acceleration is I alpha. Next, I is equals to mr squared. So when the R is greater, I will become greater, meaning that the resistance is greater. It's very hard to rotate. Okay, and when R is small, okay, I will become smaller. Smaller I means the resistance is small, so it's easier to rotate. Okay, example 1, consider an oxygen molecule rotating in the xy plane about the z-axis. The mass of each oxygen atom is 2.66 times to the power negative 26. So this is oxygen atom with the same mass. And the separation between them is d equals to 1.21 times 10 to the power negative 10 meter. Okay. Calculate the moment of inertia of the molecule about the z-axis. Okay, so you need to find the moment of inertia, and this is the axis of rotation. Okay, so the moment of inertia of the molecule is summation of I, where I1 for the first atom and I2 for the second atom. So this atom is a particle, so we need to use formula mr squared. Okay, so r is the distance between the particle to the axis of rotation. So the r would be d over 2. Okay, the same goes to another one. So then we just substitute the value and we will get the moment of inertia of the system of the two atoms. Okay, number 2, a solid cylinder has a mass of 8 kg and radius of 25 cm. Mass and r. Calculate the moment of inertia of the solid cylinder. So this one you have to refer to the list of formula. Okay, so the formula for solid cylinder is this one, half mr squared. Okay, so do not use this one because this is for particle, this is for solid cylinder. So half mr squared. So this is the mass of the solid cylinder and this is the radius. So you will get the answer. The unit is kg/m squared. Then the torque that can produce an angular acceleration of 3 radian per second squared. So we have look at another formula for torque, which is I alpha. So I is the one that you have calculated here for the solid cylinder and alpha is given. So this is the torque. Okay, number 3, a cable is wrapped around a uniform solid cylinder of radius 10 cm and mass 5 kg. So the question mentions that this is a uniform cylinder. The cylinder rotates about its axis through its center and the cable unwinds without stretching or pulling. And then if the cable is pulled, bila dikenakan force of 200 Newton, find the torque applied to the cylinder. Okay, so there are two formulas for torque. Torque equals to Ft and another one I equals to alpha. So which one you can use based on the parameters given? Okay, we can use F and D because F is the force applied 200 and D is the moment arm. Okay, so remember this is the line of action and this is the moment arm. So the moment arm is basically the radius. So we use torque equals to force, which is the tension, times with the radius. So we get the answer 20 Newton meter. Okay, we cannot use this one because we don't know what is the alpha. For B, the angular acceleration produced. Okay, so now that we know the value of torque, we can use another formula I alpha, then we can find the angular acceleration equals to 800 radian per second squared. Okay, next find the tangential acceleration produced. So in the diagram, this is the alpha. For tangential acceleration is going straight. Okay, so it is the tangent of the rotation. And one formula that relates the tangential acceleration and the angular acceleration is AT equals to R alpha. Just substitute, then you will get the answer. Okay, D, the angular velocity, omega, of the cylinder and the number of revolutions after it rotated for 2 seconds. So you are given the time after 2 seconds, meaning this is the final angular velocity. And then number of revolution. Okay, you need to find the theta first. Okay, so we need to find the final omega. This is the omega naught equals to 0 plus alpha t. Alpha we have calculated 800. And then the t given is 2 seconds. So this is the final angular velocity. So from this final angular velocity, we can find the angular displacement. Okay, substitute the value of omega. Omega naught is 0, 2 alpha, and we can get theta. So theta is in radian, in which 1 revolution equals to 2 pi radian. Now that we have 1600 radian, how many revolution? Okay, so you just do the cross multiply, you will get 254 revolutions or rotations.